Apparently there was some difficulty in the video lesson with this part of the lecture, so I thought I would do a small recording so you could see what was missing. We remember that the definition for prime numbers is that they have exactly two factors, 1 and itself. I also said in the lecture that a number is divisible by 3 if the sum of the digits is divisible by 3. So you add up the sum of the digits, and if that sum is divisible by 3, then you know that the number itself is divisible by 3. I always think it's a good idea if we memorize all of the prime numbers from 1 to 100. And most of you know that 1 is not a prime number. It is also not a composite number. So I'm not going to cross it off because I've asked us to cross off composite numbers. And I'm not going to circle it because we're being asked to circle all of the prime numbers. 1 is one of those special numbers. It has exactly one factor. It is neither prime nor composite. Hopefully you know the prime numbers from 1 to 10, 2, 3, 5, and 7. There are 4 prime numbers less than 10. That means that each of these are not prime. You know, that's a bit annoying. Maybe I could just highlight the numbers that are not prime. Or highlight the box. That might work. Okay, so not prime. Not prime. Not prime. There we go. Let's think about 2. 2 is the only even prime number. That means that all of the other numbers on this list that are even are divisible by 2, and therefore they have more than 2 factors. These are all even numbers. They are not prime. These are all even numbers. They are not prime. All even numbers, not prime. Even, not prime. And even, not prime. Is there another column that we can get rid of straight away? Well, of course, the numbers under 5. 5 is a prime number, but every other number ending in 5 is divisible by 5. So that means these numbers are also not prime. So look what we have left. Not that many numbers to think about. In every set of 10 numbers, you only need to consider the numbers ending in 1, 3, 7, and 9. And if I look at that that second row, 11, 13, 17, and 19 are all prime numbers. Our first concern was to get rid of numbers that are divisible by 2. Now we should get rid of all of the numbers that are divisible by 3. So if we look at the next row, 21, if I add the digits, 2 plus 1 is 3. This is a number that's divisible by 3. 3 times 7. So we know that 21 is divisible by 3 and not prime. 27 adds up to 9. It's divisible by 3 and not prime. Why don't you pause the video and see if you can cross off all of the other numbers divisible by 3 and therefore not prime. None of the numbers in the 40s that are left are divisible by 3, but 51, 5 plus 1 is 6, divisible by 3. 5 plus 7 is 12, divisible by 3. None of the numbers left in the 70s are divisible by 3. 81, divisible by 9 and 3. 87, 8 plus 7 is 15. It's divisible by 3. So all of these numbers that I've highlighted in orange are composite numbers. They are not prime. What about the numbers that are left? How many are there? More than 25. Remember that there are 25 prime numbers less than 100. Well, we've got rid of the numbers divisible by 2. We've got rid of the numbers divisible by 3. We've got rid of the numbers divisible by 5. What about numbers divisible by 7? Now, there's no quick and easy trick for this, so we just need to look through the list. Can you pause this video and find the numbers divisible by 7? Maybe I'll highlight those in a different color. We know, of course, that 49 is divisible by 7 and therefore not prime. 77 is divisible by 7 and therefore not prime. Do we have any other numbers that we can get rid of here? We have to get rid of one more. There are only 25 prime numbers less than 100. So here's a hint. There's only one prime number in the 90s. 97 is 7 times 13. The remaining numbers here are the prime numbers less than 100.